All right. So here we have a particle in motion, and what we're going to do is talk about the different ways to interpret our position function. I don't know why I just put a parenthesis there. Okay. And this is the position graph. So what you're given here is our position graph. So if you take a look, each one of these is labeled with an S. And I know it's a little bit hard to read. These are a little bit blurry. Okay? And we are looking at the position at time t sub 0. So, I mean, you can interpret these graphs in many different ways, but we're specifically looking at t sub 0. So you have to make sure that you're looking at that specific spot. Okay, so the first thing that we're asked is the position at t sub 0. So what we're looking at here is the location of the graph in relation to the x-axis at that time. Because this portion of the graph right here is above the x-axis, that means the position is greater than 0. So the particle is above, basically it's above the x-axis if you want to write an explanation. So the particle is above the x-axis. I mean, that's really what we're looking at. Where's the location? Above or below? So if you take a look at the third graph down, what do you think that's going to be? Yeah, this would be less than 0, but we'll get to that in just a minute. Okay, V of t. What is the relationship of the position graph and V of t? What is V of t to the position? That's right, it's the slope. What is the slope at this point?
Positive.
Yes, so we would say greater than 0. So what this means, let me write right here, we're looking at the slope, okay, just so we know what we're looking at. Okay, and what this means is the particle is moving in the positive direction. Particle is moving in the positive direction. Okay. Okay, if V of t is the first derivative, and that's the slope, what do we use the second derivative for in terms of graphing? What are we looking at? Concavity. Okay, so here, for A of t, we're looking at concavity. And I'm not going to write this for every single one. I'm just going to write it for the first one so we know what we're looking at. At t sub 0, what is the concavity? Greater than or less than 0? Less, it's concave down, less than 0. So A of t is, so we're saying acceleration is negative, true? So here, the velocity is decreasing. The velocity is decreasing, concave down. So, let me ask you, if we had to describe the particle at t sub 0, would you say the particle is speeding up or slowing down?
Slowing down.
Why? Think about what we just talked about in that table. All you have to do is give one small explanation.
The velocity and acceleration are different signs.
There you go. That's all you have to say. So in this case, the particle is slowing down, and your justification would be because V of t and A of t have different signs. Or you could say opposite. Try to keep it as simple as possible, right? Keep it simple. Okay, questions on the first one. So now this should move a lot quicker. Okay, now that we know what we're looking for. Here we are, position, greater than or less than? Greater than, why?
Above the x-axis.
Yes, above the x-axis. All right, so V of t, what are we looking at?
Slope.
We're looking at the slope. So greater than or less than? Less than 0. So what would you say? The particle is moving in the negative direction. So if you had to give a description here, particle is moving in the negative direction. Okay, what about A of t? Less than 0. Why?
Because
Concave down. So what would you say about the velocity? The velocity is decreasing. Decreasing. Look at the previous. Velocity is decreasing. So then what would I say if A of t was greater than 0?
Velocity is increasing.
Velocity is increasing. Okay? So we're using the very first one as our template for what we're going to say in terms of a description. J. J.
But
Earth to J. Yes, but velocity is less than. Okay, velocity, particle is moving. If this is going to be, this is greater than, so if it's less than, that would be moving in the negative direction. Particle is moving in the negative direction because velocity is negative. Remember, velocity gives us magnitude and?
direction.
You got that straight. Okay, so then acceleration, okay, tells me what the velocity is doing, increasing or decreasing. He doesn't like.
I understand.
You know, likey. Okay, so what's the description about this particle? Tell me. Mm-mm.
I know it's positive to positive,
Okay, I
but isn't
understand.
Negative to negative, yes.
Could it be slowing down because it's going
No.
under?
No, it's
No.
It's speeding up. It's going negative. It's still going faster and faster.
Yeah, so if this is 0, okay, it's not moving right, it's moving
It's speeding up.
in the opposite
But
direction.
it's not going
Okay, it's
below the point.
Go ahead.
It's still speeding up because it's like even though it's going negative to like less than.
No, that's not the reason I'm saying we don't see it going under the x-axis.
It has nothing to do with the location of the position. It has to do with what's happening to the particle. Is the particle speeding up or slowing down? So if acceleration is negative, okay, meaning the velocity is decreasing, really what's happening, if your velocity is decreasing in the negative direction, they are going together. So it's going to pick up speed in the opposite direction versus in the positive direction. So then what's happening is if your acceleration and your velocity are the same, they're going to go against each other, so that's why the particle is going to slow down. Because one's trying to go this way and the other one's trying to go this way, so it's opposite forces. So here my description would be the particle is speeding up, and your justification would be
Because velocity and acceleration are the same signs.
perfect. Velocity and acceleration have the same sign. Okay, so we said earlier, you guys told me that the position of the particle at time t sub 0 is less than 0. Could I say something about whatever this time was? It would be different, right? If I did. But here they're talking about this one, so that's why this is the position. So the particle is on the negative side, boom, below the x-axis. It's just location. So what about v of t at this time? Greater than or less than? Think about the slope. Yes. Slightly negative, right? So it would be less than 0. So we would say that the particle is moving in which direction?
Negative.
In the negative direction. Okay, and what about acceleration?
It's
Greater than 0. Why?
Talking about
Yes, concavity. So we could say that the velocity is
Accelerating.
increasing. It's okay. The acceleration is increasing. So what about the particle? Speeding up or slowing down?
slowing down.
Why?
Because they're opposite signs. Velocity and acceleration are opposite.
That's right. Try to avoid saying they, okay? But you caught yourself, and that's fine. Because then really, who are they? We're talking about acceleration and velocity. Perfect. Okay. This is very different. Okay. Position at time sub 0.
Greater than
Yep, greater than 0. Still located above the x-axis, right? Velocity. What is it?
0.
It's equal to 0, right? Horizontal tangent line. So the velocity, excuse me, is equal to 0 at time t sub 0. So what does that mean? Go back to what does that mean? What?
It's not moving.
Oh, yeah, particle has momentarily stopped. The particle has momentarily stopped. Momentarily. How long? For a moment. I have no idea. Momentarily. Okay, acceleration. Yeah, negative, concave down. Okay, so velocity is, think about it, momentarily stops, so velocity is decreasing, okay? So what can we say about this particle if the velocity is 0? It's not moving, right? Particle is not moving at that moment, t sub 0. Okay, questions on using a position graph to give you an idea of what's happening with velocity and acceleration? Okay, take a breath. What I want you to do right now, Okay, we're going to see this graph again. Yes, dear, I'm sorry.
For the description, would you say the particle is not moving at t sub 0?
Yes.
That's how you read it.